I just wanted to talk through this physics question just to talk about some exam technique because it's quite complicated and it uses lots of physics equations. So let's look at question 1a. The diagram shows two measuring cylinders and the scale values are in centimetres cubed. What is the volume of the liquid in measuring cylinder A? Well, if you read it, it's 60 and it's 60 centimetres cubed. Oh, that's quite hard to read, but there you go. Right, if the liquid has a density of 0.8 grams per centimetres cubed, what is the mass of the liquid? So you need to use this formula triangle, which has density, mass, and volume. So if the question is what is the mass, mass equals density times volume, which is 0.8, times the amount, so that's 60. And therefore the answer is 48 grams. So I hope you can see that I used the formula triangle that involved all three values. I substituted in my numbers to get 48 grams. So now the next question is a show that question. So show that the weight of the liquid is 0.48 newtons. Okay, so in this circumstance we need the equation which links weight and mass. Remember, weight in newtons equals mass in kilograms times gravity. Now, we need to convert 48 grams to a kilo, so we need to divide by 1,000, so that's 0.048 times gravity. Now, gravity on Earth is around 10, so we'll times it by 10, and look, we've got our answer of 0.48 newtons. So that automatically tells us that it's correct because it matches what the question wants us to know. Okay, question 2 is slightly more complicated. We've got a measuring cylinder filled with water to the 200 centimetre cube mark. Then we have a lump with a mass of 400 grams which is lowered into the water, and we need to work out the new volume, which is therefore going to be a combination of the liquid plus the lump, whatever that is. So what we're going to do in this case is we're going to rearrange our density formula triangle and we're going to look at volume. So volume equals mass divided by density. We've been told that the mass is 400 divided by the density, which we've been told is 8. So therefore the volume is 50 centimetres cubed. Now don't make a mistake at this point. Remember, you have to add that to the initial volume because obviously we're looking for the volume with both the water and the lump in. So the total will be 200 plus 50, which is 250 centimetres cubed. So you need to draw a line around there. Oops, that's not very straight. I hope that's helpful. It's basically a way of understanding how all these equations link together and how you can use them to answer some pretty tricky questions.